Okay, so first we will solve the homogeneous. Differential equation. I'll work it with you as you do it. So that's just y double prime plus y equals 0. The characteristic equation for this is just r squared plus 1 equals 0, which would give us r equals plus or minus I, which we can immediately recast our y complementary as c1 sine plus c2 cosine. No? Okay. And now we go to the non-homo, yeah? Okay. So that's when we're gonna encode. We're gonna say y particular is u1 y1 plus u2 y2. This here is y1 and this here is y2. And for that we need the Wronskian, yeah? So that's just cosine x sine x derivatives. So minus sine x, and the derivative of sine x is cosine x, and then we take the determinant of this, which is cosine squared x minus minus becomes sine squared x, which is 1. The Wronskian is 1. Okay?
I got negative 1.
It doesn't matter because you switched your
right,
y1 and u2. Yeah, it doesn't matter. So then u prime 1 will be minus y2 times g of x divided by the Wronskian, and u prime 2 is just y1 times g of x divided by the Wronskian. Okay, we'll do each one separately here. So we'll start with u1, u prime 1. So u prime 1 is equal y2 is sine x minus Wronskian is just 1, and the g of x is the non-homogeneous term. So this here is g of x. Tan x. So this becomes minus sine x. And tan is just sine x over cosine x. Okay? And now, of course, this is du1 over dx equals minus sine squared x over cosine x. And we can separate the variables. So we can remove this dx, put it here, and then we can integrate both sides. So we get u1 to equal minus, okay, now sine squared we can rewrite it as 1 minus cosine squared x over cosine x, yeah? Dx. Did you know how to integrate this one? And then we can split it. So 1 over cosine is just secant x dx, and the other one is minus cosine, the integral of cosine x. Or no, dx. Okay, now the cosine is fairly straightforward, which is sine x. But how do we integrate the secant? There's a trick to integrate the secant. Let me tell you what the trick is. Otherwise, you're going to have to get yourself into lots of partial fraction decomposition and so on. The trick goes like this. We multiply up and down by 1 plus tan x secant x. Already? Let me try to remember if that's the trick. Secant square. Let me try to remember if this is a trick. Tan secant. Let's try to remember if this is the right trick. No, it's secant plus tan. I remember now. It's secant plus tan. We multiply it by secant plus tan. Let me erase this. Show you why. So we multiply here by secant x plus tan x, and we multiply here by secant x plus tan x. Okay? And the reason we do this is because when we continue here, we will get secant squared x. No? Over plus secant x tan x over secant x plus tan x. Okay, now let me tell you why this is helpful. This is helpful now because there's a dx here. Because when you call secant x plus tan x u, gu will be the derivative of secant is secant tan plus the derivative of tan is secant squared. So you get exactly the numerator when you do this. So we're going to use substitution here. Okay? So u is secant x plus tan x, which would make du to be secant x tan x plus the derivative of tan is secant squared x dx, which is exactly your numerator. So the integral now becomes, I'll go back to dark red here, so minus the integral of du over u, and the next one we integrated minus sine x, so we get ln u. Minus sine x. So the answer for u1 is minus ln U is just secant x plus tan x.
So secant x
minus sin x. Okay? That's our U1.
So you said you multiply.
You'd multiply the top and the bottom by secant x plus tan x. Because when you take your denominator to be u, your numerator becomes exactly du. The entire thing becomes du. No? Okay, so this was a tricky part, u1. Okay, now we'll go get u2. No? So, u prime 2 is equal to y1, which I called it cosine x, times g, which is tan x over 1. Now this is a straightforward one. Cosine tan is just sine x. So that means GU1 equals, because tan x is sine x over cosine x. Okay, so GU1 is equal to sine x dx. And now I can integrate both sides. And I would get u1 to be minus, the integral of sine x is minus cosine x. Okay, so now I can write down my y particular. So y particular is u1. Oh, sorry, this was u2, not u1. You already found u2. Okay, so u1 was minus ln secant x plus tan x. First, it's yeah, minus ln secant plus tan. Already, minus sin x times y1. What was y1? We called it cosine x plus u2. Oh, times. Yeah. So y2 is sine x times minus cosine x. So this becomes a minus cosine. So this here is y particular. And now we can write y general. So y general will just be y complementary plus y particular. So we get y general to be c1, y1, c1 cosine x times this whole mess here. So cosine, there's already a cosine x, so this becomes cosine squared x times, I'm going to factor out the minus sign, probably easier, and then the inside is just ln secant x plus tan x minus sine plus sine x, factor out the minus sign. So this is u1 times y1 plus c2 times sine x with Okay. I think I wrote this wrong. It's here. So y general will be, or y particular, which is all that up there. So minus cosine x, no, and secant x is tan x. I factored out the minus sign plus sine x. Okay, minus sine x cosine x plus y complementary. So this whole thing was y particular, and y complementary is c1 cosine x plus c2 sine x. Now, only after you are done writing the general solution, you can solve for the coefficients c1 and c2. Not at the beginning. So now we are told that y0 is minus 1. So plug this in. So we get minus 1 equals cosine 0 is 1. This is 1 plus 0, ln 1 is 0. I'm going to do this quick because this is just algebra 0. So this first term entirely goes to 0. The second term sine 0 is 0. The third term is cosine 0 is 1. So we get c1, and the last term is 0. So that automatically gives us c1 to be minus 1. Because there's a minus 1 on the left-hand side. Left. Okay. Oh boy, now we need y prime. Okay, that looks like a nasty one to do y prime for. Yeah. But let's go ahead and do it. So y prime general. Okay, so product rule on the first one. So that's just sine x times the second as is. Now, the second as is got me a 0. So I really don't need to evaluate this. Because from y of 0, it got me a 0. So I can skip that part. Minus the first, plus minus means minus. This first as is times the derivative of the second. So that's 1 over ln is secant plus tan is 1 over secant x plus tan x times the derivative of secant x plus tan x, which is the derivative of secant is secant tan, and the derivative of tan is secant squared x. So that's just all the ln, plus the derivative of sine is cosine. So that's the derivative of the product rule on the second part. Okay, and now minus sine x cosine x product rule. So that's minus derivative of sine is cosine. So minus cosine squared x. And then sine times minus cosine. So it becomes a plus sine squared x. Now the last two terms are simple. C1 cosine is minus sine, but C1 is minus 1, so this becomes minus sine x. And C2 cosine x. Okay, great. So this is y prime of g. So now I know that y prime of 0 is 1, yeah? So that means if I plug in 0 here, this term here is 1 over 1 is 1. And this term here is 1. So let me write this in a different color. So this is 1 because secant 0 is 1. And this here is 1. And this here is 1. So 1 plus 1 is 2 times 1 is 2. 2 plus cosine 0 is 1 is 3. So this guy here is 3. And cosine 0 is 1, so that's minus 3. So this whole thing gets me minus 3.
For
minus cosine squared. Yeah, go ahead. Cosine squared 0 is 1.
For U2, did you get ln tan
This-
x plus sin x?
Ln tan x plus secant x.
Let's see.
Yeah. This guy is 0. And this is 1. So C2. And this is equal to 1. Which makes, if we solve for C2, we get minus 4 plus 4, we get 5. Okay, finally. So now all we have to do is plug these into the general solution and we're done.
Isn't you said to multiply
To integrate it, yeah, you multiply the top and the bottom by secant x plus tan x.
oh, secant x plus tan x?
Yeah, otherwise you don't get the right u and du. Okay, so then finally we can write the general solution.
Wait, isn't I multiplied
minus cosine x. Okay, you multiplied it?
I multiplied by secant x times tan x. Then when I simplified, I got it to secant x tan x over tan x. And isn't that the derivative of tan x over tan x?
With it.
Yes, right. But I multiplied by secant tan x over secant tan x. And then I simplified, that comes to 1. So I got secant tan x over tan x, isn't that?
Wait. How could you multiply here by secant tan and not multiply here by secant tan?
I did. I just erased it because I was.
But then this becomes secant squared. When you multiply by secant tan.
No, I erased part of it. It's it was 1 originally. It's 1 over cosine x. So 1 over cosine x times secant tan over cosine secant tan, which that comes to 1, so it becomes that.
How did this tan become on the numerator?
And multiplied by secant tan over secant tan.
I'm not following you, what you're saying actually. Well, write it down. You're erasing stuff. I can't see what you're saying. So,
This is what I did. It was 1 over cosine x, so I multiplied it by secant x tan x over secant x tan x.
Okay, fine. Then?
And so the cosine x and the secant x become 1.
Fair enough.
So I get secant x tan x over tan x.
Okay, fine.
Isn't that the derivative of tangent?
No, yeah.
So wouldn't that mean that it's ln of tan x? Because it's the derivative of tan x over tan x.
No, the derivative of tan is secant squared.
Oh.
The derivative of secant is secant tan.
Oh, okay.
So that's why that doesn't work. So minus sine x cosine x. C1 is minus cosine x. And C2 is 5 sine x. Okay, this was a long problem, but finally we got it solved. This is the general solution of the non-homogeneous second-order linear ordinary differential equation using variation of parameters.